Okay, here is the first class after the first test. We're going to talk about chapter 5, centroids, or center of gravity. You have a beam, whatever the shape is, excuse me. The center of gravity is in the middle, right? But if you have something like this, or maybe even something like this, trapezoidal shape, rectangular shape, easy, triangular shape, any shape. So that's the topic for today. You can solve center of gravity or the centroid, I call it centroid a lot, by either one, integration direct, integration method, or DIM, direct integration method. X bar, centroid of x-axis, or horizontal, or longitudinal. Integral a to b x, and the integrand f of x, we need to find this, dx integral a to b f of x dx. If you took calculus 3, I think, yeah, calculus 3, or not, even probably calculus 2, the area underneath the curve is this guy. So this is defined as the area later on. Y bar is the same. Integral x, nope. Y, f of x, f of x, nope. F of y, dx, dy, dx, dy, f of x, f of y, integral. If you want to change here, c to d, just not get confused. I'll explain this in a second. How important is this topic in real life? 0. How important is this topic in real life? 100%. If you're a civil engineer or a structural engineer, whatever it may be, you have to know this stuff, this part. But this, or this, reflects this. So this is the simplified version. So, x bar, big X bar. Integral, it doesn't matter, by the way. Don't get confused. Integral, what is integral? Sum, right? So sum, I equal 1, the first index, or the first shape, is 1. Second one is 2. I have 3 total, n equal 3 in this case, if you have 3 total. AI is this AI. Do you think this is AI? Yes, it is. Because in math, integral f of x is the area. X, xi, same thing, except different notation. It doesn't really matter. I write it that way. If you write it differently, the same thing as here, I don't have any problem. Integral, the sum, this is called big sigma, summation, AI, f of x integral, the same thing. Just review the relationship between integral and summation, identical. The same thing. Y bar, integral, sum, y, f of y, a. This is a. Integral, sum, ai, f of y. So, I will not focus a lot on this topic, or this method, let me say. This is the most important thing. I do this daily basis. A beam looks like, I'm just give you a second to catch up here and erase it and tell you what I'm talking about. Okay. Assuming that you are a bridge engineer and you are trying to find the centroid of bulb T, Colorado bulb T, it looks something like this. That's your cross section of the beam, and obviously extended to have the length of the span, right? Well, where's the centroid? Most likely those are not equal to each other. The thickness of the top flange is not the thickness of the bottom flange. So here comes X bar and Y bar. This is bar, not prime. So hypothetically, you assume here's your reference. Where is this located? Is it closer to the top flange or bottom flange, or in between both of them, or just in the middle in the web area? This is top, oops, top flange, bottom flange, web, sometimes called stem. So that's why it's really important topic. And it's not just for beam, it could be for any shape. So I'm not gonna focus a lot on the first method, even though that a lot of people focus on it. I'm gonna touch on it pretty quickly, even though you're gonna have a homework assignment on it, but it should be really simple. Let's solve one. X, Y. X equal 2, let's say 4. Let's say this is square root x. Find x bar and y bar using, or the centroid, direct integration method. Direct integration method. Well, let's see. X bar defined as integral x f of x over integral f of x dx dx. Clearly, I'm going from 0 to 4. 0 to 4, 0 to 4. Well, here it comes. F of x would not just be this guy. It might be. Who knows? F of x for dx perspective, top minus bottom. I'll explain right now. That's the way I do it. I don't know if you understand it differently. It's up to you. I do it top minus bottom. Why? Because you're doing dx. Here's your dx. Right? Well, your dy, or technically your area, is going to be x by y. X is dx. F of x is going to represent y. So this minus that. Just like a calculus in our class, pretty much. So your f of x in this example is square root x minus donut. So that's square root x. Rest should be really simple and easy. I'm gonna go ahead and erase this and plug and chug. Integral 0 to 4 x square root x minus 0 dx over integral 0 to 4 square root x dx. Please don't do this. That's not math. That's basically just your own math. So, you cannot do this. Sorry, not today. Everyone should be able to integrate this. I'm going to integrate it really quickly because I'm pretty sure most of you know it. X times x to the 1/2 is x to the 3/2. Integral that, it's x 5/2 to 5th over x to 3/2 to 3rd, 0 to 4. So that's equal to square root 4 is 2, 2 to the 5th is 32, so 2 over 5, 32, divided by 2/3 times 2 to the 3rd is 8, so that's 4, and that 1, so you've got 4 over 5 times 3, which is equal to 12 over 5, 2.4. Hypothetically, this is inch. I'm not here to solve exactly the whole problem with after I set up this. That's your task, most likely. Let's talk about solving y bar using DIM, direct integration method. Next to class, hopefully tomorrow or Saturday, Todd, we are going to be talking about the other method, which is the most important method, and Centroid, obviously, topic. So this chapter, the way I discretize this chapter, if you don't know what does discretize mean, that means break down, just kind of like categorizing. I do direct integration method, 1, 2, composite area method, or sometimes called it subparallel axis theorem. That's just my definition. And then reactions using distribution load, which that's a total topic. I don't know why the book is putting this topic in the same chapter. But anyways, might do like a separate video for that. Y bar, using direct integration method, integral y, f of y, let's set up the equation first, excuse me, and 0 to something. How to find that something? Let the x equal each other. Square root x equal 4, so x is square, or x equals 16. Right? Am I making sense? No, I'm not. Why? Because if you're doing this, that means your here should equal that one. So you plug in x to find y. So if you are plugging 4 here, so you're going to say square root 4 equal 2. At this location, you've got 2 y value. So 0 to 2, 0 to 2, y prime, or y bar equal integral 0 to 2, y f of y. The way I define f of y, remember what I said for f of x? Top minus bottom, right? For f of y is right minus left. But this is square root x. This is f of y. Well, simply, that can be written as 4 minus y equal root x. So x equal y squared. I'm pretty sure every one of you should know this, at least. So 4 minus y squared over 4 minus y squared, 0 to 2, dy, dy. You could integrate this simply. The concept is pretty simple. It's pure math. what you need to do is just make sure that you could set up your functions, whether x or y, correctly. Then you could go from there. Y bar equals 0 to 2, 4 times y. I'm going to integrate in one step because we're not doing integration here. So 4y, integrate that, 2y squared, y to the 4th over 4, 4y, y to the 3rd over 3, 0 to 2. Right? Y times 4, 4y. Integral 4y is 2y squared. Y times y squared, y to the 3rd. Integral y to the 3rd is y to the 4th over 4. Same thing bottom, or denominator. So that means 2 squared is 4, so 8 minus 16 over 4, 4 over 8 minus 8 divided by 3, so that is equal 4 over 8 minus 8 over 3, that is 16 over 3, I think, and that is what? That is 12 over 16, so that is 6 over 8, and that is 0.75 inch. And then you could say your centroid, just a summary, if you would like to do that. What was it? 2, I think, 0.4, something like that, and 0.75 inch. Boom, 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 boom. And you are golden. You are good to go. Next time, I'm not going to talk about direct integration method. I will assign one a problem direct integration method. You could have fun with it. It might not be as fun as you expected, like it's not really challenging because it's not really important topic for engineers, practical engineers. And I promise one of my mentors and boss, and he's my friend John Bott, that I will not teach the non-useful topics. So next time we're gonna do the more practical way, or the common way to do centroid using composite area method. Just a quick introduction. If you've got something like this, and you have something like this, obviously, dimensions are given. Where is the centroid located? Next time we're going to talk about this. For now, I will sign off, and please let me know if you have any questions. If you have any problem with integrals or integrations, definitely highly recommended review the integration properties. I will see you next class, hopefully tomorrow or Saturday. Peace.